Good afternoon. Hello everyone. I'm Dr. Kajal and I'm going to take a topic on chi-square test. So, what is a chi-square test and what is the importance of chi-square test and where should we apply this chi-square test is very, very important. Okay. So, first of all, I'll tell you the contents which I'm going to take. That is, first of all, is the introduction of the test. Then you should know what are the conditions means where we should use this test. Then what are the different steps for the application of this chi-square test? What are the applications and how to calculate chi-square? I'll give you some examples as well. And what are the limitations of this test? So before starting this, we should know what do you mean by parametric test and non-parametric test. So the parametric test, chi-square test is a non-parametric. So you should know what is a parametric test. So parametric test in which the population constants like the mean, standard deviation, standard error, correlation coefficient, etc. are given and data tend to follow one assumed or established distribution like you have read about normal distribution. So the data it follows those and you are given in the paper on the article about the population constants like the mean standard deviation standard error. Then the parametric test will be applied like the t-test or the ANOVA and the other tests. Now what is the non-parametric test? So the test in which no constant of the population is given. It is the most useful test. The data do not follow any specific distribution and no assumptions are made in this test. That is to classify as a good, better and well, best, we just allocate arbitrary numbers or the marks to each category. Okay. So in the question, if there is no mention of the population constants and the data is not following any distribution, then we will use this test. Then the hypothesis is what do you mean by the hypothesis? It is a definite statement about the population parameters. Next is what are the different non-parametric tests. So the important one which you should know at your level is chi-square test. Although there are different non-parametric tests as well, but you should be aware about chi-square test. So what are the conditions for the application of this chi-square test? That is the data must be in a precise numerical value. So this is very important. That is the absolute numbers are there. There is no mention of proportions or the percentages. And the data must be organized into categories. That is qualitative data like yes or no categories or the disease or not disease or the patient is positive or negative. So like these, the qualitative data is there. Okay, so precise numerical value and the qualitative data. These two things are there. Then you should apply for chi-square test. Observations are recorded and used are allocated, collected on a random basis. Now, chi-square test is an independence test. It is used to find whether there is an association between two things. Okay, this is just chi-square test is not a test for the strength of association. It is just to find that whether any association is there or not. Okay, to find the association between two variables, we use this chi-square test. So in this chi-square test, we make a table and table represents the joint occurrence of two sets of events. So the table which is made is known as a contingency table. So it is usually asked in the question that make a contingency table. So one wants to know the association between two sets of events or two variables is called the association table. And when there are only two samples, each divided into two classes, it is also called as 2 by 2 table. Okay, 2 by 2 or 4 contingency table. So now comes what are the different steps for the chi-square test. First of all, you need to define null and alternative hypothesis. So what is null hypothesis? What is alternative hypothesis? That I'll explain. Then we need to state the alpha error. So what is the alpha error? That I'll also explain in the further slide. Then you need to know the calculate the degree of freedom. Then the decision rule. You need to calculate the chi-square test and then give the interpretation. So these are the different steps for the application of chi-square test. Okay. So now comes what is the general formula for calculating chi-square test. So this is the sign for chi-square is equal to summation of observed value minus expected value ka whole square divided by expected value. So O stands for the observed value which are given to you in the question. E is for the expected value which you need to calculate, and I'll explain you how to calculate the expected value from the observed value. Okay, and then you need to sum for all the values. Now state alpha error, alpha value. Alpha error or alpha value is a type 1 error that is rejecting a true null hypothesis. So always remember that is alpha error or type 1 error is rejecting the null hypothesis when it is actually true. Means although it is true, but even then we are rejecting it. Okay, so that is the alpha error for majority of the studies. Means because of our error we are rejecting it. So for majority of the studies we keep the alpha as 0.05. Okay, meaning the investigator has said 5% as the maximum chance of incorrectly rejecting the null hypothesis when it is actually true. Okay, so this limit is set as 5%. Usually most of the studies जब भी हम पढ़ते हैं तो हम क्या बोलते हैं कि this value is significant at the level of 5%. Okay, so now this is the table of chi-square distribution in which you need to see the value under 0.05. Okay, so the degree of freedom in the first column, if you see, the mention is df. Df is degree of freedom. So at 1 degree of freedom and level of significance is given. Okay, over the top columns, if you see top row, so you need to see at 0.0050. So under that heading, that is, we set our limit as 5% chance of rejecting the correctly uh, null hypothesis को we are rejecting. Okay, so you need to see at the level of significance 0.05. मतलब कि जब भी आपको टेबल दिया जाएगा तो आपको उस chi square टेबल में जो 0.05 का वैल्यू है उसके अंदर देखना है और किस डिग्री ऑफ फ्रीडम पे जो भी आपकी टेबल पे निकल के आएगा. यूजुअली इट इज 1. So at 1 degree of freedom, the level of significance 0.05, the value is 3.841. This is the value, and ये table आपको usually provide किया जाता है exam में. You need not to mug this table. Then state the decision rule, that is if the value obtained is जो value हमने calculate की है अगर वो if it is greater than the critical value of chi-square, what is the critical value which is given in the table, then the null hypothesis will be rejected. Okay, so the value which you have calculated is greater than the critical value which is the table value, then you will reject the null hypothesis. Okay, so now state and interpret the results whether the value of chi-square is more or less. If it is less than the critical value, then we will accept, and if it is more, which we have already told you, then we will reject our null hypothesis. Okay, now what are the different steps in calculating chi-square? सबसे पहले हमें क्वेश्चन से you need to make a contingency table or 2 by 2 table or 4-fold table mentioning the frequencies or the data which are given in the table. You need to mention them. Then you need to calculate the expected value in each cell. Now comes कि हमें expected कैसे calculate करना है. जो मैंने आपको बताया, तो आप जब भी टेबल बनाओगे तो उसमें रो का टोटल, उस पूरी जो भी टेबल है उसमें रो का टोटल कितना आ रहा है इनटू कॉलम का टोटल कितना आ रहा है डिवाइड बाय द ग्रैंड टोटल. So R into T divided by capital T. So that is row का total into column का total divided by grand total. You will calculate the expected value. Then you will calculate the difference between observed and expected value in each cell. For calculating chi-square, you need to know the difference. Okay. Then calculate the chi-square for each cell. You will calculate जो हमारा जनरल फॉर्मूला है that is observed minus expected का whole square divided by expected. Then you will do the sum of all the chi-square for each cell to get the chi-square value of whole table. Okay, that is summation of observed minus expected the whole square divided by expected value. For example, consider this is very important to understand the whole concept of chi-square test. You need to go through this example. So consider a study which is done in the hospital where cases of breast cancer were compared against controls from normal population against possession of a family history of CA breast. मतलब कि हमने दो ग्रुप्स लिए हैं. एक ग्रुप लिया है केसेस का which are having the cases of breast cancer. दूसरा कंट्रोल है जहाँ पर की नॉर्मल पॉपुलेशन लिया है और उनमें हम देख रहे हैं कि कितने फैमिली हिस्ट्री ऑफ सीएफ ब्रेस्ट इज देयर. So 100 in each category were studied for the presence of family history of cancer. So 25 of cases and 15 among controls had a positive family history. मतलब तो टोटल 100 लोग थे जिनको ब्रेस्ट कैंसर था केसेस, उनमें से 25 लोग ऐसे थे जिनको की फैमिली हिस्ट्री ऑफ ब्रेस्ट कैंसर वाज पॉजिटिव, और जो हमारे 100 लोग जनरल पॉपुलेशन के थे उनमें से 15 पीपल वर हैविंग a positive history of family cancer. Okay. Then comment on the significance of family history in breast cancer. मतलब कि क्या association है between the family history of breast cancer and person developing the CA breast. Okay, उसके बीच में. So we want to test the association between these two things कि CA breast का and family history of CA breast का कोई relation है या नहीं. So solution from the number, it suggests that family history is 1.66 times, that is 25 upon 15 times more common in CA breast. So it is a risk factor in population. अगर हम ये statement पढ़ते हैं तो हमें क्या लग रहा है कि it is a risk factor in population. So we need to test for the significance of this difference. So we will apply for chi-square test. Okay. So solution, first of all, step one, set up the null hypothesis. So what is the null hypothesis? That is, there is no significant difference between occurrence of family history among cases and controls. Means family history of cancer is playing no role. So null hypothesis is the hypothesis of null, means there is no association. Hypothesis of no association between these two variables. Then alternative hypothesis is family history is 1.66 times more common in CA breast as compared to general population. Then we will step 3 we will calculate the chi-square. So we will make a contingency table. So this is how the contingency table is made. That is, on one side, first column we will always mention risk factor. Then the another side we will mention in the second column breast cancer, means the disease is present or not, breast cancer history, breast cancer disease yani ki cases are there, and breast cancer negative, that is controls. And last column will be our total. So in the first row we will mention family history of risk factor है, CA breast का family history is positive जिन लोगों में है, and another row में family history negative. So breast cancer के total cases were 100. So उन 100 में से family history were positive in 25. So we mentioned that is A. Then family history was negative among 75%, that is B. Then breast cancer was absent, that is control group, but the family history was positive in 15% and family history was negative among 85. So this is how our family history positive in this total 40 लोगों में and family history negative in 160. And our total population cases plus controls is 200. Okay, so this is how the contingency table is made. Now we will determine the expected value in each cell. तो हमने क्या बताया था? How we will calculate, that is row का total into column का total divide by grand total. Okay, so our for A, for calculating A, that is for जो 25% है A जो है उसके लिए हम expected value, ये 25 is the observed value. Now we will calculate the expected value. So row का total is 40 and column का total is 100. So that is 40 into 100 divided by grand total is 200. Okay, so this is how 20 comes. So for A जिसका कि observed value हमारे पास 25 है, उसका expected value कितना आया? That is 20. Similarly for B we will calculate, that is B का अगर हम देखते हैं तो 75 है जो ऑब्जर्व वैल्यू है, तो उसके लिए हमने कैसे कैलकुलेट किया? रो का टोटल इज 100 इनटू कॉलम का टोटल इज 160, ग्रैंड टोटल इज 200, सो इट कम्स 80. सो दिस इज हाउ वी विल कैलकुलेट फॉर ई ए बी सी डी के लिए हमने अपना एक्सपेक्टेड वैल्यू कैलकुलेट किया फॉर एवरी वैल्यू इन द सेल जो भी ऑब्जर्व वैल्यू है, दैट इज हाउ वी विल कैलकुलेट द एक्सपेक्टेड वैल्यू. नाउ कम्स, हमने इसको मेंशन किया फॉर ए के लिए ऑब्जर्व वैल्यू वाज 25, एक्सपेक्टेड वाज 20, ओ माइनस ई कम्स 5, ओ माइनस ई का होल स्क्वायर इज 25, और हमने अगर का स्क्वायर निकाला उस ए वैल्यू के लिए, इट कम्स आउट टू बी 1.25. सिमिलरली फॉर बी, ऑब्जर्व वाज 75, एक्सपेक्टेड वाज 80, ऑब्जर्व माइनस एक्सपेक्टेड इज -5, इसको हमने स्क्वायर कर दिया तो हमारा माइनस साइन चला जाएगा, दैट इज 25. chi-square comes 0.3125. For C value, observed is 15, expected is 20, O minus E is 5, O minus E का whole square 25, chi-square is 1.25. So this is how. Then comes grand chi square, हमने जो कैलकुलेट किया, ग्रैंड टोटल किया, o माइनस ई का होल स्क्वायर अपॉन ई का समेशन किया सारी chi स्क्वायर वैल्यूज का 1.25 प्लस 0.3125 प्लस 1.25 प्लस 0.3125, it comes out grand chi square is 3.125. So this is our calculated chi square. Now we will see कि जो calculated value है वो हमारे टेबल वैल्यू से कम है या ज्यादा है. ओके, सो नाउ वी विल डिटरमाइन फर्स्ट ऑफ ऑल डिग्री ऑफ फ्रीडम. तो डिग्री ऑफ फ्रीडम का फॉर्मूला होता है जो हमारी कॉन्टिजेंसी टेबल है उसमें रो का टोटल -1 मल्टीप्लाई बाय कॉलम जितने भी हैं -1. तो हमारी टोटल रोज कितनी आ रही हैं? टोटल रोज हैं 2 इन दिस टेबल. सो 2 -1 मल्टीप्लाई बाय अगेन 2 -1. So the grand degree of freedom comes out to be 1. Okay. So now we will find out the corresponding p value. So p value can be calculated by using the chi-square distribution table. So हमने जो पहले आपको बताया था इस chi-square table में अंडर द डिग्री ऑफ फ्रीडम जो 1 है उसके अंदर सिग्निफिकेंस लेवल हमने ऑलरेडी सेट किया हुआ है 0.05. सो वैल्यू इज 3.84. सो दिस हमने जो कैलकुलेट किया दैट इज 3.125. So that is less than 3.84. So we will accept the null hypothesis, that is there is no significant difference between the occurrence of family history among cases and controls. Okay, so we will accept the null hypothesis, that is there is no difference between cases and control on the basis of family history of cancers. So we can use the softwares as well. For I think I am clear till now कि how to calculate this null hypothesis. Because आपको एग्जाम्स में यूजुअली कैलकुलेट करने को होता है या फिर आपको कैलकुलेटेड वैल्यू दी जाती है एंड आपको टेबल से वैल्यू को देखना आना चाहिए एंड यू नीड टू इंटरप्रेट इट कि अगर हमारी जो कैलकुलेटेड वैल्यू है इफ इट इज लेस देन द टेबल वैल्यू देन वी विल एक्सेप्ट द नल हाइपोथेसिस and if it is more than then we will reject the null hypothesis. Now comes what are the limitations. The test can be applied in a 2 by 2 table, will not give a reliable result if the value in any cell is less than 5. तो अगर किसी भी सेल की जो वैल्यू है वो 5 से कम है ऑब्जर्व वैल्यू, then this test is not correct. We should apply the Yates correction. What is Yates correction? उसकी डिटेल में जाने की जरूरत नहीं है आपको, ठीक है. तो आपके लेवल पे you should know this only. Then it does not measure the strength of association. This test does not indicate the cause and effect. It only tells the probability of occurrence of association by chance. Okay. तो मैंने जो बताया ये हमें स्ट्रेंथ ऑफ एसोसिएशन नहीं बताता, ये हमें सिर्फ क्या बताता है कि whether any association exists or not. The test is to be applied only when the individual observations of the samples are independent, which means that the occurrence of one individual observation has no effect on the occurrence of any other observation in the sample under consideration. That's it. That is whole about chi-square test. So if you have any query, you can mail me or you can write it to me or you can inform Chaitali madam as well. So thank you so much.